Okay, welcome to 4.6 inverse functions. Today we have we're gonna learn about inverse functions. So in inverse functions, whenever you put it into that original function, you will get an x that you will get like the input x. For example, f of inverse f of 4 will get you 4 because a function puts in whenever you put the inverse of a function into a function, you get um, the number back. So, well, I have some examples right here. F(x) equals ax. You switch the f of x. You could also do y equals ax and then switch the x and the y position to solve for the y, but that's not extremely necessary. So for example, let's fill in this. F of x is equal to 3x minus 5. Switch the x and the f of x positions. You add 5 to the other side. You'll get x plus 5, and then divide by 3. You will get divide by 3, x plus 5 divided by 3. So we're going to find some inverses. Okay, first of all, we switch the positions. X equals 1, 4, f of x, f negative 1 of x plus 3. Negative 1 means 1 over, but it really just means inverse. So we subtract 3 on both sides, right? And then x minus 3 is equal to 1 4 of inverse f of x. Multiply by 4, you will get 4x minus 12 is equal to inverse f of x. Simple. Next, find the inverses. G of x is equal to x plus 3, x minus 7. Now, we gotta make it so that there's one x in order for it to be easier to handle. So let's make it so that it's one x in order for it to be easier to handle. By doing this, we can complete this. We can complete the square. If we want to do this. So I'm gonna do x. We're gonna multiply this out. We'll get x squared minus 4x minus 21, right? And then after that, you can combine the equation to get x minus to get x minus 2. You can complete the square, get x minus 2 squared, right? But we have to add 4, so we have to subtract 4, so x minus 2 squared plus 25. X minus 2 squared minus 25, I mean, x minus 2, yeah, x minus 2 squared minus 25. And then we can put this as g of x. So then, therefore, we can switch g of x now with the x. And then we'll do x equals g of x, g inverse of x minus 2 squared minus 25. Add 25, x plus 25. And then we can take the square root as well, so square root. And then we can cross that out, equals g negative 1 of x minus 2. We can add 2 to both sides. We will get the inverse of g is equal to 2 plus the square root of x plus 25. And that is the answer. Next, we could do plus or minus as well. Plus or minus works because, but then that wouldn't be a function anymore. So if you add plus or minus there, it wouldn't be a function anymore, which is not a good thing. H of x is equal to x squared plus 8x plus 16 times x plus 4. What is the what's the solution? So if you look closely, x squared plus 8x plus 16 is also equal to x plus 4 squared. If you complete the square, it will be equal to x plus 4 squared flat, just x plus 4 squared, which makes it really good because now we can add it to x plus 4, which will give us x plus 4 to the third power. Now we can switch h of x and x, and then it will be super nice. It'll be really, really nice. Actually, let me see if, yeah, my answer definitely fits good. So, x is equal to h of x plus 4 all cubed. So we can take the third power, no, you can take the third root. Now we have the third root of x is equal to h of x plus 4, and we can subtract 4 to get third root of x minus 4 is equal to inverse h of x. Simple. Oh god, it doesn't even fit. Right there. The third root of x minus 4 is equal to h minus 1 of x. There you go. Okay, L of x. L of x is equal to x plus 6 minus 8. Now, there's only one L of x, so we can do it. We can switch x and L of x. So x is equal to the square root of L inverse of x plus 6 minus 8. We can add 8 to both sides. We'll get x plus 8 is equal to square root of L inverse of x plus 6. Looks like a 1. Looks like a 1. So I'll just do the mathematical. There you go. L. Square both sides, and then subtract 6. Simple. Now we have L inverse of x is equal to x plus 8 squared minus 6. And that's the answer. And it says, keep this in mind, the original function is reflected across the line y equals x. And you'll see this right here. The next, inverse analysis. We'll analyze the graphs of inverses. So here, for example, we have g of x is equal to x plus 3, x minus 7. What did I say was the inverse? It was square root of x plus 25 plus 2. That was the inverse, right? G negative 1 of x. Right. So this is the inverse. So if we plug in values, we can start seeing this this kind of this process kind of working. So we would start seeing this be reflected kind of like this, right? Let me use a different color. We start seeing this being reflected kind of like this, and we start seeing this being reflected kind of like that. Because it's reflected, you will see this type of shape, right? It's reflected across this line right here, this line, right? This line, you will see this type of shape. However, you will really only see it from the top. If you want to really see it from the bottom, you need the plus or minus. The g negative 1 of x isn't really a function unless if you add the plus or minus in there. No, it's not a function if you add the plus or minus in there. It is a function if you don't add the plus or minus in there, and then it'll just be half of the curve. Likewise, this function right here has the inverse of x plus 8 squared minus 6. That is the L inverse x. There you go. So if you add 8, if you graph this normally, it will be 8 units to the left and then 6 units down. So it'll be probably right. It'll probably be right around here. Okay, let me change color. Okay, it'll probably be like right around there. There you go. Now this graph is a parabola. It's not because it is only a reflection. It's a reflection of this positive value of x. So we want to limit. If you want a real inverse, you want to limit the function's domain so that x is only higher than or equal to. So it's x plus 8, so negative 8, negative 6. So x is only higher than or equal to negative 8. If you want to limit the function like that. That's the real inverse. That's the real inverse. Okay, next. Now we want to verify two inverse. I forgot to put the negative thing. Verify that f of x is equal to 3x minus 1 and these are inverse functions. Now I've already said that if you want to verify it, you gotta do this because that's the definition of the inverse. So let's go. So 3 times x plus 1 over 3 minus 1 has to be equal to 3x minus 1 plus 1 over 3 has to be equal to x. So is it? Okay, so we can cross that off. We can cross that off. X, yes, that fulfills the requirement. Minus 1 plus 1 is 0. 3 divided by 3 is 1. That's equal to x, and that's equal to x. So yes, they are inverse functions. Next, verify that the cube root of x minus 1 plus 7 and x minus 7 cubed plus 1 are inverse functions. So let's do it again. The cube root of x minus 7 cubed plus 1 minus 1 plus 7 is equal to the cube root of x minus 1 minus 7 cubed plus 1 is equal to x minus 1 plus 7 minus 7 plus 7 minus 7 plus 1 equals to x. So let's verify it. What's plus 1 minus 1? It's 0. So we can do cube root of x minus 7 cubed, and then we can erase that because x minus 7, x plus 7, right? And then x minus 7 plus 7 is 0. So then that is equal to x. Correct. X is equal to plus 7 or minus 7. That gets erased. The cube root gets erased. And we have x minus 1 plus 1. That gets erased. X is equal to x. And that's equal to x. So yes, they are inverses. So we're asked to find the inverse of x if x is equal to 2x to the fourth power when x is higher than or equal to 0. That is pretty important because we want the correct inverse. So we're gonna do x negative 1 of x is equal to. We're gonna switch the position of the functions like that, and then we can take the fourth root. Actually, we can divide. We have to divide by 2 first. Divide by 2. 2 x to the 2 f to negative 1 of x to the fourth power. So to divide by 2, and then take the fourth root, and then we'll get the fourth root of x over 2, where the y, because whenever you graph this function, you will get this. You will get this whenever you graph the function. So the y, since it's like this, and we want the reflection across the y-axis, the y will be bigger than or equal to 0. Next, modeling with mathematics. The maximum Hall speed v in knots of a ball with a displacement Hall can be approximated by this function right here, where L is the waterline length in feet of the boat. Find the inverse function. What waterline length is needed to achieve a maximum speed of 7.5 knots? So we'll find the inverse function of this. We're going to switch the v and the L, so we'll get L is equal to 1.34 the cube root of v, v minus 1, and then we can get divide by 1.34 on both sides. We'll get y L over 1.34 is equal to the cube root of v minus 1 squared both sides. We'll get L squared 1 over 1.34 squared L squared is equal to the inverse of v. Simple. And then what waterline length is needed to achieve a speed of 7.5 knots? So we can just add the waterline length in there. 7.5 knots. We can add to the v, right? 7.5 knots add to the v. So then we get 7.5 is equal to 1 over 1.34 squared L squared. I'll put that in a calculator right about now. 1.34 squared is a 7.5 divided by 1.34 4 is 5.59 divided by 1.34 again is 4.176. So that's the speed that you need. 4.176 water line length is L is 4.176. That's the length that you need. Next, drawing conclusions. Determine whether the following is true or false. Explain your reasoning. If fx is x to the n and n is a positive even integer, then the inverse of f is a function. If it's an odd integer, then inverse of f is a function. So I've already said this. I've already said it quite clearly. What the answers are? The answers are no and yes. But I'm gonna show you it again because showing is the way that you will learn. So, for example, let's do an even simpler line, right? Okay. So x of n, let's say n is a positive even integer. Let's say it's 0. That's the lowest positive even integer. I don't even know if it's considered positive or not. But x is 0. Let's say we have y equals 3, fx equals 3, right? fx equals 3. This will just be our line, right? If we take the inverse of that line by reflecting it through the y-axis, we'll get this. And this is not a function in any way, shape, or form. This is not a function in any way, shape, or form. If we actually have a squared, we'll do y equals x, fx equals x squared, like this. Okay, I should have put that in a different color. I'm really sorry. Fx equals x squared, like this. Then we'll also get a non-function because this is not a function. It's not a function because if you take the inverse, it's not going to be a function though. It doesn't pass the line test. Whereas, okay, so we're gonna do an odd function now. We're gonna do f of x is equal to f of x equal to x plus 5. Okay, f of x equal to x plus 5. F of x equal to x plus 5. So then now we can graph our function. It will probably be something like this. There you go, right? And then when you reflect this function across the line y equals x, you will get f of x equals x minus 5, which is still a function. Look, still a function. See, still a function. Still a function. Okay, let's do fx equals third root of x, right? So now it's definitely, no, actually we need an integer. So fx equals x cubed. Let's say x cubed, right? So fx equals x cubed will give you the inverse will be cube root of x, because the inverse of x cubed is cube root of x. So I need to graph this first. There you go. That will be the graph right there, right? And then we'll get this as our inverse. Well, I need to change color. There you go. We'll get this as our inverse. And this is definitely an inverse of x cubed, and it is definitely a function as well, because there's no sharp turns. There's nothing that repeats twice. You can't get two inputs for an output. That's gonna be it for today's episode. I said I was going to teach a new subject, and I am going to teach a new subject. You just wait right there. It'll probably be released sometime in May, but not right now because I'm really busy with other stuff, including preparing for the AP test. But I hope you guys are all having fun from this pandemic. I know it's not the best way to learn from distance learning. It's not the best way to learn from school. And I hope that many of your family members are fine. for this pandemic because it is not a fun thing to deal with, and I couldn't go outside for a good 7 weeks now. So I hope you have a nice day.